Hi, welcome to Algebra 2. This is lesson 31. We're going to talk about negative reciprocals, perpendicular lines, and remote interior angles. We're starting on page 141. The reciprocal of a number is its inverted form. So 2/5 is the reciprocal of 5/2. 5/2 is the reciprocal of 2/5. Negative 1/4 is the reciprocal of negative 4/1. 3 is the reciprocal of 1/3. Okay? The sign of a number is the same as the sign of its reciprocal. If 2/5 was positive, then 5/2 is positive. If negative 1/4 is positive, then negative 4 on this side also has to be, negative. If it's negative 1/4, then it has to be negative 4. Negative reciprocals have opposite signs. So negative 2/5 is the negative reciprocal of positive 5/2. Negative 1/4 is the negative reciprocal of positive 4. Positive 3 is the negative reciprocal of negative 1/3. Okay? Remember when we're graphing parallel lines, we found that parallel lines have the same slope but a different y-intercept. So if we graphed y equals 1/2 x plus 2, and here's a graph of that. Move this guy over. Here is y equals 1/2 x plus 2. And here's the line. And we graph y equals negative 1/2 x minus 3. We're going to find that they are parallel lines. And we could have told that if we had looked at the equations, because they share the same slope. The slope of this problem is negative 1/2. So every time x increases 2 times, the y decreases 1 time. So starting here at the y-intercept is 2, so we're 0, x equals 0 and y equals 2. Every time the x increases 2, the y decreases 1. So that's a negative slope, and the slope is negative 1/2. This slope is also negative 1/2. So its y-intercept is at negative 3, where x equals 0, y equals negative 3. And every time x increases 2, it decreases 1. Increases 2, it decreases 1. Okay? So that makes these two parallel lines. The slopes of lines that are perpendicular are negative reciprocals of each other. So if y equals negative 1/2 x minus 3, just like this line, our slope is negative 1/2. The line that's perpendicular to that is going to have a slope that is this slope's negative reciprocal. The negative reciprocal of negative 1/2 is going to be positive 2. Okay? So here's a graph of these two lines. Here's y equals negative 1/2 x minus 3. It's the same line as this one. And here is the graph of y equals 2x plus 1. So on this line, where x increased 2, y decreased 1, in this case that has been flipped. So our y-intercept is here at positive 1, and where x increases 1, y increases 2. Okay? So we have the reciprocal and a negative sign, where this was a negative slope, this one's a positive slope. And because they are perpendicular, that means these two lines meet at a right angle. So we can say that y equals 1/2 x plus 2 is parallel to the line y equals 1/2 x minus 3. And y equals negative 1/2 x minus 3 is perpendicular to y equals positive 2x plus 1. Okay? Because because we know that perpendicular lines are going to have the negative reciprocal of the slope, we can find the equation for perpendicular lines without having to graph them. So let's try that. Write the equation of the line that is perpendicular to y equals 2/5 x minus 3 and passes through the point 3 and 2. Okay, so the original line is y equals 2/5 x minus 3. We see the slope is positive 2/5. We want a line that's perpendicular, so we're going to take the negative reciprocal, which is going to be y equals -5 halves x. And it didn't give us the y-intercept, so I'm just going to put plus b here to start with. Okay, we don't know the y-intercept yet, but they gave us a point. So we can substitute the 3 for the x and the 2 for the y and solve for b and find the y-intercept. So we have y equals 2, which equals -5 halves times positive 3 plus b. And now we can solve for b. So 2 equals -15 halves plus b. You can add 15 halves to both sides. Those cancel. This is 15 halves and 2 is 4 halves. So this is going to be 19 halves equals b. It's ugly, but it's correct. So the equation of the line that's perpendicular to y equals 2/5 x minus 3 is going to be y equals -5 halves x plus 19 halves. Now we're going to talk about remote interior angles. A polygon has one interior angle at every vertex. So for angle A, or for this triangle, we have 1, 2, 3 interior angles. If we extend the sides of this triangle at C, boop, 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 boop. So if we extend the line here at C, we've got this line going this way and this line going this way, we see that we have two exterior angles. We have this angle right here and we have this angle right here. And this angle is the opposite angle to this one. So this is actually going to equal C. So we're going to call this angle E. Okay? Because angle A and angle B are on the other side of the triangle from our angles E, we're going to call these two the remote interior angles. And we can prove that angle E equals angle A plus angle B. Okay? So we're going to prove that angle E equals A plus B. We know that A plus B plus C equals 180 degrees because it's a triangle. We can see that angle C plus angle E equals 180 degrees because it makes a straight line. So C plus E equals 180 degrees. Using Euclid's sixth postulate again, if A plus B plus C equals 180 and C plus E equals 180, that means that A plus B plus C equals C plus E. And once again, using the eighth postulate, we know that if we subtract C from both sides, that means that what is left, A plus B, has to equal what's left on the other side. So A plus B equals E. Your math text actually puts a QED after that. That is Latin, and it means that which was to have been demonstrated. So we have demonstrated what we set out to prove, that E equals A plus B. Okay, that is it for lesson 31. Try your practice problems and let me know if you have any questions. Thanks.